Thanks so much for joining us today. Today's webinar is called Wi-Fi, Public 5G, or Private Network, What's an Enterprise to Do? I'm Catherine Speglia, the Technology Editor at RCR Wireless News, and I'll be moderating today's discussion. Joining me today is Karim El-Maki, the President of Athonet, Stefan Dublé, the Head of Marketing at Nokia, and Safi Khan, the Regional Product Marketing Director at Telit. Please use the webinar portal to submit questions throughout the conversation, and our speakers will get to as many of those as possible towards the end of our time. Also keep in mind that we are recording this webinar and the slides and video will be made available on demand. We're here to discuss some of the things enterprise decision makers should keep in mind when selecting connectivity solutions for their facilities. With Wi-Fi and 5G advancing somewhat parallel to each other in the form of Wi-Fi 6 and 5G, network architecture is becoming more flexible, but also more complex. As a result, many enterprises are left wondering what the best solution to meet their specific needs might be. Further, nearly every sector from healthcare and education to manufacturing and utility is undergoing massive digital transformations aided by tools like artificial intelligence, IoT sensors, and automation. Such tools are great, but they also put pressure on existing networks and require more advanced connectivity. Historically, the enterprise space belonged to Wi-Fi. However, Wi-Fi has some well-known challenges around coverage, reliability, and security, leaving the door wide open for cellular technology to fill in those gaps in the form of private wireless networks, either powered by 4G LTE or 5G. When used inside of an enterprise's facility, cellular technology can be an extremely reliable tool. And can provide reliable and secure solutions to connect critical assets if it is deployed and managed correctly. Of course, not every enterprise is going to opt for a private wireless network, and even fewer will choose to have every single application run on a private network. Instead, many will continue to use Wi-Fi, as well as public cellular in some areas of their networks. With that, I'm going to hand it over to Stefan, who will delve a bit deeper into where an enterprise might need a private network and where they might consider sticking with 5G or public cellular.
Thank you, Kat. Can you hear me? Very good.
Yes,
I'll stop the video to save on uplink bandwidth a little bit. Okay. And thanks for all joining today. So I wanted, from the beginning, really just give you an answer on what is Nokia's view when it comes to effectively the choice of technology. Just by that picture, I think that there are clearly, a need for all of those different, type of technologies and type of choice of architecture. So really, we see that, as we deploy, private wireless networks, but also public networks with our CSP and also, around the Wi-Fi side, we really feel there is a sweet spot for each of these technology. Next slide. Thank you. So let's tackle first the public or private approach. So in our sense, if you take a look at an enterprise, and most segments have needs for both what we call industrial sites and industrial campuses, all the way to nationwide, and or even somewhere in the middle. For example, take the utility that also need what we call field area network. They need connectivity, across their assets. For example, the grid for a power utility, or the rail, for a train company. So in that sense, there is a need for critical connectivity across the board, with obviously, again, a choice of different solutions. The first one, that we are talking about today is private wireless network, which is something that's reasonably recent, and we'll be covering that in depth today. But private wireless networks are effectively a very small network, scaled down to scale to the enterprise size, and really fitting the specific requirements, both in terms of coverage and capacity, really providing the maximum availability and reliability in their site, and then providing them really full control and data privacy. So this is why, the private wireless network today are being so attractive and are really seen as a growth market for both vendors as well as mobile operator. On the flip side, if you need a nationwide network, for example, if you're a big delivery company with trucks going all around the country, you will need very large coverage, even beyond nationwide, even global. And in that sense, there's no better way to do that, and no more cost-effective way to do that, but to leverage the mobile operator public network And then with 5G, as most of you know, we'll be able to slice that part of the network to provide a certain guaranteed of KPI. And then, if the mobile operator deploy a dense enough, edge architecture closer to the point of consumption, we'll also be able to guarantee a level of SLA when it comes to also low latency. So these are effectively the two extremes with a lot of things in the middle. For example, we've seen in many instances, utility company or rail preferring to use private wireless networks for their field area network, effectively following their assets and their grids and their rail. But at the same time, maybe it's not economical in some instances to effectively deploy their own network. So they can also, again, with the technology we talk about, 4G, 5G technology, they can combine private and public as well. So combining a private wireless network that maybe cover 90% of their requirement for their field area network, but complementing it with a mobile operator public network. So that's effectively, for me, tackle the first part. There is a need for both private and public networks, and most of the enterprise will probably need both. Next slide. So now when we talk about technology, there is clearly, as Kat mentioned, LAN and Wi-Fi technology have been long embedded into most enterprise. But when you take a look at an industrial site more specifically, but the same can be said of a nationwide requirement, there are different requirements within the same industrial site that spans from what we typically would call IT all the way to what is typically called operational technology. And again, the requirements are very different, often driven by different teams as well. On one side, on the IT side, you need to provide connectivity to the employee mobile services. You need to provide effectively, the 4G and 5G for them to connect their phones, for example, when they are at work and on the site. At the same time, you'll have your enterprise control LAN and Wi-Fi for providing the connectivity for day-to-day business application. But if it's an industrial site, what you'll find as well, you've got also critical application that are normally driven by the OT team with very specific requirements on availability, reliability, security, etc. That goes beyond the capability of the technology on the left-hand side. And that's really where we see the place of private wireless network with both 4.9G and 5G over time, really providing significant differentiation in that space, and I'll come back to that. So again, we don't see private wireless networks taking the space of Wi-Fi in the IT domain, but we feel private wireless networks are better suited and meeting better the requirements from the OT application that we are seeing. Next slide. So there is obviously a lot of discussion around 5G, and it is correct that 5G will bring over time fantastic capability when it comes to industrial use cases. But the experience from Nokia having started private wireless back in 2015 is 4G technology has evolved over time since release 8 of the 3GPP standard and all the way to release 15, and brought significant enhancement when it comes to capability that are important for the industrial. So today, with 4.9G network, which is the latest generation of LTE 4G, we are able to support over 85% of use cases for industrial. This was based on research done by Nokia Bell Labs. As you can see here, these are an example of some of the things that our customers are calling us about, some of the things that they're having issue with or application they need to implement that we are delivering today with private wireless 4.9G LTE networks. From a utility that have to adapt their, the way they generate power with more distributed types of power supply with wind, wind and solar farms, having to balance loads and production and the change in production of all those different renewable sites, to the mining place where they have to guarantee employee safety and the site security as well, all the way to enhancing their efficiency with more automation, for example, with autonomous trucks. From airport, helping all different enterprise working on below the wing processes to prepare the plane and be coordinated to make airport more efficient. Same thing with the port, effectively making them move from the world where they're effectively using all the technology to a world where everything is automated from the receipt of the container all the way to the dispatch. And then finally, in the manufacturing space, where although the manufacturing are very advanced in terms of automation, they can gain a lot with wireless technology when it comes to flexibility and adapting their productions. So these are all the things that those vertical needs. And one of the first things that is often requested is digital twin, effectively creating a real-time digital view of what's happening from all the assets in the field. And again, this is something that 4.9G can do. Next slide. Thanks. So I'm going to present you some of the recent testing that we've done with Nokia Bell Labs together with Aalborg University in Denmark, where, as we talked about, we feel there is really, a need for all the different technologies and approach. At the same time, we also wanted to verify the difference in performance between the different technology. So we've effectively working together with that university when they have a very advanced manufacturing site in the university that we are also leveraging to be able to test the different technology in a real industrial environment. So I'll be first of all looking at at the aspect of loading and multi-user capacity, comparing the different technology and architecture. So the first Kat, thank you. On this one, as you can see, the first thing we tested is we tested effectively the difference between a public LTE network and a private network and different kinds of private wireless network. So the chart here is showing on the x-axis the latency, and on the left-hand side the probability of you getting that latency. So if I take a look on that chart, if for example I'm looking at the blue line, in 99% of cases, the public LTE network will effectively guarantee me 100 millisecond latency. Okay, so that's effectively combining latency as well as reliability, which is very critical for most industrial use cases. So as you can see from this chart, the line on the right is showing a public LTE network where we connected to the public LTE network, working together with the operator in that country. And as you can see, although we had a single user on that network, there may have been some load because we're effectively sharing the coverage, and there may be somebody that walking outside and connecting to the same radio. And as you can see here, that gives us a latency that's a little bit unpredictable, because after around 99.5%, beyond that, you may get a latency that's above 150 milliseconds. Now, one of the model of private wireless networks is just using the public network core, but putting a small cell inside the location. And in that case, you start to have a much more stable latency. At the same time, you can see that we still have to transport effectively some of the control signal and the data in that case all the way back to a core network that may be a few hundred kilometers away. So when you go for a full private wireless network, you can see that effectively that gives you an additional shaving of about 20 milliseconds of latency and a lot better reliability all the way to 4 nines. So now, next click. So now if we start loading that network, and then we're going to compare Wi-Fi 5 and Wi-Fi 6. So one more click. So as you can see now, we've got a single user on the private LTE network, and now we've got two other networks in the same environment deployed in the same location. And as you can see, the Wi-Fi 5 and Wi-Fi 6 networks actually provide really, really good latency, all the way to around 99.93% of cases. And Wi-Fi actually does a pretty good job when you've got a single user. Now let's take a look at the difference, because really this is really critical. Predictable performance is key for industrial use cases. So let's take a look now if we start loading the private LTE network versus the Wi-Fi and see what happens. One more click, Kat. And then one more. So as you can see, with the private LTE network, and thanks to the Cellular built in 3GPP technology for a long, long time, we effectively have a much lower impact on loading. So that means you can keep a very stable latency, even with a reliability of 4 nines, keeping a latency of below 100 milliseconds. In comparison, when you start loading the Wi-Fi network, and we're still waiting for enough Wi-Fi 6 devices to be able to also repeat the test, as you can see, the Wi-Fi network significantly lose predictability in terms of its latency, but also in terms of capacity as you go above 90%. That means, in 10% of cases, you will have a latency that's significantly higher than private wireless. And this is really something that's very important when we take industrial applications. And if you want to know the number for 99.99% of cases for Wi-Fi, we reach 1.2 seconds, which is just not acceptable for many industrial use cases. So now let's take a look at the other benefit of private wireless, which come with mobility. So one more click. So again, we're back from the same starting point with Wi-Fi 5 and Wi-Fi 6, and then private LTE with a single user. This is a static, which means not moving. The UE is in a static, in a fixed position. So now one more click, and you'll see again the difference. So with private wireless network, there is a handover time that takes between 30 to 50 milliseconds. So what we can guarantee for things that move is a latency that is below 150 milliseconds, even for 4 nines. Now, if we do one more click, you'll see the difference with Wi-Fi. So Wi-Fi effectively is not designed for mobility beyond pedestrian speed. And as you can see, the impact is shown also rapidly on this one, showing a significant increase in latency as we start to do handover. That we also seen doesn't change at all with Wi-Fi 6. So anything that move, basically, like you have autonomous trucks, travel carrier in a port, AGVs in a factory, as you can see, this is a big, big difference also in terms of technology. Next slide. Right, that'll be my final slide. And I'll stop on there, but I want to show that on that slide, private wireless is clearly, picking up. We're still in the very early part of the market. There's over 14 million industrial sites out there in the world, and many also public sector side that will require private wireless. And although we are effectively doing quite a bit of traction in that space with Nokia, and it's really going across the world, we barely scratched the surface. So that's why you see such a big interest in the market. A lot of the analysts forecasting really big number, because private wireless is critical for the digitalization of industry. And as part of the industry 4.0, it really provides significant benefit. And that's why we'll see probably the market growing significantly in the future. Thank you.
All right, thank you, Stefan. Now, Karim will discuss how the cellular industry is changing and where it's heading as it pertains to private wireless.
Hello, so glad to be able to talk to you. My name is Karim Al-Malki. I'm one of the founders of Athonet, and I'd like to talk to you today about our experience and the deployments we've made. And it's really one strong thing that I think now the private LTE and very much 5G, we all know that the focus of 5G, and we'll hear about it later today, but the focus of 5G is really industrial and private deployments. We're in the deployment phase. There's lots of networks that are deployed. We've been doing it for 10 years, and I'd like to share some of the learnings and things we've seen along the way. Next slide, please. So a little bit to start with about Athonet, and we've been running in this segment, the private LTE and 5G segment, for 10 years now. So it's been quite a while. And the idea really was, what we wanted to do and what we've been doing for the last 10 years is implementing and deploying private LTE and now 5G for enterprises, organizations, including hospitals, airports, ports, public safety, manufacturing, schools. We have large numbers of deployments of this type around the world, 500,000 SIM cards actually running live in these networks that are giving us some incredibly useful feedback and very positive feedback, which brings me to say that now is the time and it's really ripe for private LTE and 5G. Athonet's approach is one of trying to make the network as easy and as invisible as possible for enterprises. And that's really been a new paradigm, starting from some of the world firsts. I mean, we did the first LTE for public safety in 2010, 2012. The problem isn't really getting the technology out there. It's not the same technology that you find in mobile operators. It is making it really easy for an end user that is not a telco user to be able to leverage it. And that's really been the fundamental requirement for us building our connectivity platform. And this segment has already recognized private LTE and 5G, the whole industry, as important. Athonet ourselves, we won 4 Global Mobile Awards in 2019, which signaled the way and which is really was really the beginning of this market becoming adopted widely. Please, next slide. So the cellular industry is changing, and this is the situation that we used to have, which is Wi-Fi being the technology used in the private domain in an enterprise running on unlicensed spectrum. And of course, many of us are using Wi-Fi today on our mobile phones to do Wi-Fi calling, for example, or just to connect to Wi-Fi and do our data while we're indoor, and therefore public as well. Wi-Fi has been used for public use too. And then again, unlicensed spectrum. While LTE and cellular technologies were being used for public access, your national network where you travel wherever you want and you've got your mobile phone, your tablet, and you're connected, right? Typically over licensed spectrum. Now, The difference, what LTE could bring and what we could see that that could bring to the table are the characteristics that are that I have on the right. So you have coverage, first of all. Therefore, you can cover wide areas in a cost-effective way, simply because of the spectrum and also the transmit power and the sensitivity that you get. You get performance. I mean, you get very good bit rates at the edges of the network in places where you don't have great signal. Security, very nice. You've got SIM cards that you plug in your devices, which make management of security really easy. You got control. The enterprise, in general, the end user, and in our case, the enterprise, can actually have full visibility on the network of what's going on, who's connected, where they are, what traffic characteristics they can do right now. And mobility, they can move, and that's quite obvious, and we're used to that. Next slide, please. Now, sorry, one back. So the characteristics, these characteristics that I just talked about, have actually created a great advantage for LTE 5G in the private domain as well. But there was one blocking aspect, and the blocking aspect was spectrum. The precious license spectrum, there's not a lot of it, and it's hard to come by if you want to do an enterprise deployment. Now, there have been a lot of changes. There have been a big paradigm shift with open spectrum happening. We're talking about Cbrs in the US, we're talking about France, the UK, we're talking about Japan, we're talking about lots of countries around the world that have been adopting lightly licensed spectrum, call it that way, or unlicensed spectrum, where enterprises can, and operators on behalf of enterprises can build networks dedicated to enterprise using this spectrum. And bringing all these advantages of LTE and 5G to the enterprise domain, which wasn't available before. And really, this has been the big shift that has enabled a lot of these networks. Next slide, please. So this has been an enabler, the spectrum has been an enabler, and the technology brings some advantages, but does it just mean that you can take the technology that is being used by operators and just give it to an enterprise? There's been a lot of confusion around this because there's been we're in the hype cycle. There's a lot of discussions about 5G, what it can, what it can't do. There's a lot of discussion about slicing, and there's some assumptions sometimes that is a private network, and slicing is not really a private network. For those who are interested, I've tried to cover this aspect in one of the blogs on the Internet side. So how do you actually go about building such a network? Well, there's the bottom half of this slide, right? You can see radios, devices, and spectrum. Now, those are common that you have in operator networks, right? You use your phones, you use the spectrum, and you use the radios, whether macro or small cells. You use them also in private networks. The key thing is you have to be very flexible here, because enterprises have special types of deployment needs. You may have an airport that has very large areas to cover, and therefore you may want devices that could be 5G or LTE Wi-Fi bridges, or could be tablets, and you may be using radio base stations that are macro cells because they need to transmit on very wide areas. At the same time, you may need to cover smaller areas, whether indoor or outdoor, and therefore require small cells. These are all products that are there. The shift here is making them easier to deploy, in these kind of settings, but pretty much the technology is there, and you have to be flexible. Now, really the missing thing, which is what we very much focused on, was what we consider to be the platform, right? That you're seeing in the Wi-Fi space a lot. And the connectivity platform, what this is, the way we view it, is the core network, which is the element that is actually missing in Wi-Fi, and that is there in mobile networks. The core network controls all of the traffic and the devices, the mobility, the radio management, and so on. The SIM management, and a dashboard that can give the end user access to be the end user, be it an enterprise, an airport, a port, a hospital, access to see what is going on in their network. Now, this is a layer that is fundamental, and that we believe enterprises need to customize, need to own. because that is the heart of the network, the intelligence, where they can be on top of which they can build their applications. And that is critical because we're seeing edge computing coming on. We're seeing a lot of applications that can be enabled by a private LTE or 5G network, thanks to the advantages that we mentioned before. But you actually need a platform that makes it all easy to manage for the enterprise. That is very different from an operator. You actually cannot give them the same product. It would be an overkill, not only economically, but also from a management and an operations point of view. If you can go to the next slide, please. So we've played with a lot of technology, and we've had a lot of experience. We've come up with several solutions that aim to satisfy the needs of these enterprises. Now, two important points there: the cloud, the automation, and the edge computing. These are technologies that I think have been fundamental and are being fundamental enablers for private 5G and LTE. Cloud and automation, we've launched our 5G product running on the cloud. We have hybrid cloud deployments on 4G deployed in many countries right today. The cloud and automation means that you can drive down the cost of the network, make it simple to implement, and make it simple to manage for the end customer. And we've seen that happen already in the enterprise space. And this is exactly what needs to happen in the private 5G LTE space to cater for these new needs. And edge computing. At the same time, enabling applications is fundamental through the APIs, through allowing enterprise to move loads, sometimes from the cloud to their local enterprise premises, because they need that for the low latency and so on. So again, enabling the applications there is fundamental. A connectivity platform that enables all of these, and in this case, what you're seeing actually is a photo of an edge device, an edge device, an AWS Snowcone in this case device, that can be deployed at the edge of the network and automatically configures itself, connects to the cloud, and is running, and on which you can run edge applications. Now, the moment you have a platform like that, then private 5G LTE becomes an enabler to do something that makes sense from the business point of view, and not only from the technology point of view in the wireless term. And this is what we think is fundamental to break down the barriers, knock down the barriers in deploying cellular technology, typically used in different contexts within the enterprise premises. And with that, thank you very much.
All right, thank you. And finally, we have Karim, who's, oh, I'm sorry, Safi, can you take us through some of the early use cases for 5G networks and how some specific verticals might put it to use?
Yes, I will. Thank you. Can you hear me?
Yes, you sound great.
Okay, great. So you can go to the next slide. Right. Okay, so I'm going to talk a little bit about 5G because that's one of the main technologies that is basically has some inherent advantages that are beneficial to the enterprise. And so, as some of you may know or may not know, again, 3GPP, the body that basically drives the cellular standards, in release 15 in 2018 released 5G. So the first wave of 5G was release 15, and this is the first time that the new spectrum in millimeter wave was introduced. And so there are actually two sets of spectrum in 5G. One is called sub-6, which is below 6 gigahertz, and one is millimeter wave, which is in 20 to 30 gigahertz range. So this opened up many new use cases beyond LTE, such as very high speed mobile computing. So the high speed of 5G is one of the key attractions for early adoption. And then the first use case that came out of that is fixed wireless access, or what is technically called eMBB, which is enhanced mobile broadband. So this is what really is being pushed into commercial and residential enterprises, commercial enterprises and residences by way of using customer premise equipment, CPE. And what this does is it basically tries to reach wired broadband speeds, but using wireless technology. And that is what's opening up many uses where your overall downlink speed as well as uplink speeds are going to have a dramatic increase compared to 4G. And especially when you have higher uplink speed in 5G, it really helps with some of the new applications where, for example, you have video and camera equipment, video broadcasting, connected cameras, Industry 4.0, smart factories. They all use heavy uplink, robotics, and so on. So many use cases open up because of that. And of course, then there is a big push for automotive market to basically make cellular vehicle to vehicle and vehicle to infrastructure connectivity and so on. So as has already been talked about, manufacturing and industry has really benefited or will benefit from some of the features of 5G that I talked about, and I will talk about in the next slides as well. Now, it doesn't stop there. There is going to be a continuous evolution. So then after release 15, which is now commercial today, there is work and already a new standard, release 16. And one of the key features of release 16 is ultra reliable, low latency communication. And that goes back to Stefan's plots, which were very impressive, by the way. I really learned a lot from that. Is basically this ultra reliable low latency is really going to help the manufacturing and robotics and machines that can basically operate on very low latency, and you can eliminate the wiring in factories. And of course, it will also help with Industry 4.0 in healthcare, and also extended reality or AR and VR and XR that you might think of. And of course, then release 17 comes after that. This is about 2 years out or 3, and then that's massive machine type communication. So massive MTC is going to allow to scale up. So as you saw in the simulation or the results that Stefan was talking about, when you scale at enterprise level, more devices on a network, that's where there are limitations, what a Wi-Fi access point, how many users it can handle. Whereas in this 5G network architecture, that's already built in, so it can scale up. So next slide, let's continue. So as I already mentioned, right, these are many use cases where 5G will make an impact, and especially 4G connectivity and ubiquitous connectivity, we're used to it. But when it comes to private enterprise, 5G will also bring in some of the advantages that have already been covered. But basically, as we progress to release 16 and release 17, and we get these new 5G features, that's basically going to help basically proliferate private networks in a mainstream. And it's going to be driven mainly by infrastructure vendors like Nokia and others, and large system integrators. They will drive this ecosystem. There is already a big ecosystem, and basically an end-to-end complete solution is basically what's needed. So that what the heavy lifting the operators are doing for like a nationwide network, a similar end-to-end solution can be basically miniaturized into a private setting and deployed by enterprises. Okay, next slide. So let's, from Telit perspective, we, you heard from Nokia, you heard from Ethernet, so that's basically how the end user enjoys these features, a customer from an enterprise. Now, Telit is more involved in the technology or the low level, the module or the data cards that enable the cellular modem and the 5G modem. So of course, 5G is first deployed in handsets, and of course, it's driven by mainly by the smartphone ecosystem. So you can enjoy all of the new benefits of higher speeds and 5G using smartphones. But what about the enterprise, right? When you have routers and gateways or infrastructure, and basically you need to provide 5G connectivity for non-smartphones, that's when you need to rely on pre-certified data cards, such as the FN980M from Telit. And what they will bring is all of the benefits of 5G NR, which is the new radio for industrial IoT. And as has already been talked about, with 5G, you will enjoy lower latency. You have higher reliability. You heard about 4 nines. That's basically 99.99%, which is what's needed by industry and manufacturing. The higher performance, of course, now we have a gigabit LTE data card, which is reaches 1.2 gigabits per second. But with 5G, we are bringing data cards that will be able to realize, up to, tens, like let's say 5 gigabits per second using dual connectivity, basically combining 5G spectrum and LTE spectrum together to give you sustained high throughputs. And then, of course, the spectrum options Karim touched on is very important. You have the shared spectrum and the unlicensed spectrum. So one of the new work items is also 5G in unlicensed spectrum, as well as the Cbrs private spectrum in North America and Europe and Japan and all of the developed markets. There is also the concept of time-sensitive networking, which basically will give you more reliable service and edge computing. So all of this is what's a good combination that enterprises can leverage to essentially have their own private network, which is more secure, more private. The data stays on premises. They can choose to keep it on premises rather than going back and forth to a core network somewhere else. So data analytics and data is very sensitive for enterprises, and that's where the cellular and 5G or private LTE and private 5G provides that benefit. And of course, coverage, we talked about that as well. In cellular, it's built for indoor as well as outdoor and coverage and longer coverage. So a small cell for a private network can reach more users and have larger coverage, simply because it is allowed to transmit at a higher transmit power, whereas a Wi-Fi access point has an upper limit on how much power it can transmit. And also the signaling and the architecture is not scalable to support so many users on a single access point. So the total cost of ownership and the CapEx and OpEx is something that really depends on what kind of a network is being deployed. And so that's where a private cellular network has these advantages that we have highlighted. Okay, so move to the next slide, please. Right. So, again, this slide is just showing only a few of the recent private 5G network announcements. And it just proves that, this ecosystem is growing very fast. Of course, there's a lot of hype as well, but then there are some real examples and real deployments, as was mentioned by colleagues from Nokia and Ethernet. For example, Nokia is selected by Toyota. As you can see, auto manufacturing is getting into this private network in a very big way. And of course, they want to have secure wireless connectivity inside their factories. They want to make all of their tools to be connected so they can run analytics, they can know, they can predict, and have less downtime, be more efficient. Similarly, Bosch, another automotive company, signed with Ethernet, a consortium for connectivity between Europe and Taiwan. And then, of course, you can see many others like operators. You know, there's also the mobile operators offering private 5G as a, like was mentioned before, as a slice from their network. But, you know, of course, it's not the same thing. But of course, they can carve out a portion of their spectrum and try to compete with the pure private networks. So there's a lot of excitement in the industry. North America is leading because of the Cbrs auction that happened, in the priority access license, and so on. So the ecosystem is healthy and it's growing. Okay, next slide. This will just, you know, kind of touch on how you can have different deployment scenarios for basically carving out the private network, and how it can benefit the enterprise. So of course, you know, think of it as a 5G island, and of course the island is basically to give you this visualization that your entire network is basically under your control. There is, you know, you have control over what devices are on the network. You control what policies you implement, what security policies, you know, how the SIM gets authenticated, and who is authorized. And then there's a single point where you can have connectivity to the internet through a firewall, and that's what protects your data. Or it can also be built by an MNO. It can be an MNO owned in a licensed frequency, and you pay for that service. And of course, it's also you know, envisioned as another a private network on a licensed spectrum. So there are different costs involved, and there's a trade-off that the enterprise has to look at. On the other hand, in a shared 5G network, there are multiple levels. And, you know, of course, if you know the network architecture, there are so many components. So you can actually pick and choose at what level you want the sharing to happen. So of course, RAN, the radio access network, sharing can be done basically at the G node B level. And then of course you have the you know, the control plane and the user plane signaling. You can do that split between basically G node B and then basically the control plane, and so on. If you go down the list, you can see you can basically have the network is very flexible, especially because the 5G NR also defined, you know, pushed more emphasis on software defined networking. So, you know, previously there were hard server boxes or separate entities in the network that had to be maintained to be compliant to 3GPP. But in the 5G network, those are now moved to the cloud-based RAN, as was already mentioned, and so on. So that helps implement this sharing more easily. Next slide, please. Of course, there are many verticals. You know, we don't have the time today to touch on all of them, but I think manufacturing is one of the main vertical for private networking that's really taking the lead. The smart factory, smart manufacturing, and, you know, eliminating the wiring, providing low latency wireless connectivity, and basically complementing the limitations of Wi-Fi. So that's basically it. I think my last couple of slides, I'll just touch on what we have to offer from Telit, especially because, like I said, we're at the heart of providing the modem for all of the appliances and the routers and gateways and CPEs. Nokia and Ethernet are providing the, you know, the infrastructure side of the network, and then all the devices is where Telit plays. And the one I want to highlight is on the top right, which is our FN980M. This is an M.2 data card with sub-6 and millimeter wave, release 15, 5G. It also has a category 20 4G LTE modem, and it has all the global bands supported. So this essentially is what will go into a router or a gateway that will provide 5G connectivity, a modem basically. And then, of course, we have the LM960 A18, which is the gigabit LTE data card, that's mini PCIe. We also have a Cbrs only variant, which are the ones in the middle. So we have a category 9, band 42, 43, and 48, LM960A9. So if you want to deploy just the private and LTE and don't want to have any of the MNO bands, you can use this cost-optimized data card. And then on the very low end, we also have our LE915 portfolio, which is Cat 4 and Cat 6. Now these can provide basically Cbrs service to, let's say, for example, in a USB dongle. And you can have a Chromebook in a school, for example. You can plug in a USB device with Cbrs service. And that's actually happening in some of the school districts with COVID and children being at home. You can basically give them, a public school can basically have a citywide Cbrs network deployed to provide connectivity to students. So that's another use case. And last slide, quickly, next one. We also have a Wi-Fi portfolio because, of course, we do have 11AC 1x1 product. And then we have the low-end single-band low-power product for very low power. And then we have a hostless in the middle, which can basically run the application on board. It doesn't need a Linux host. So Telit basically has, a complete cellular portfolio as well as a Wi-Fi portfolio for all of the needs for the enterprise. So I'll stop there, and then I think we can switch to Q&A. Thank you very much.
Yeah, thank you, Safi, for that. So we have a ton of great questions and only about 10 minutes left. So once this is concluded, we will do our best to get the remaining questions over to our speakers so they can answer those personally for you. So let's actually start with a question that I'm gonna direct towards Stefan here. So what is the scalability of an LTE solution for an enterprise customer compared to a Wi-Fi solution?
So I think when we talk about scalability, I mean, a private wireless network, as I explained on my earlier slide, can scale all the way to almost a nationwide network. So we've done deployments, for example, in Brazil with a company called Electro, which almost the size of a large European country. That's how far it can scale, because you can effectively leverage the same license spectrum that the operator are using, for example, to get to extremely large cell coverage up to several 30 kilometers of radius. And then of course you can scale down. On the lower side, one of the things that I would say is Wi-Fi networks beyond about 25,000 meters squared becomes more cost effective. So that's something to bear in mind. Typically the private wireless networks, even from a cost point of view, total cost of ownership become more cost effective beyond a certain size, and then as soon as you've got outdoor area as well. But it pretty much can scale the same way, and then much wider when it comes to a wide outdoor space.
Okay, great. And Karim, this next question is for you. What's the difference between a public and non-public network slice and secure MVNO?
It's a great question, and it's been creating a lot of confusion, actually, with a lot of our customers and people we talk to. So, I mean, network slicing is rather different from a private network. Network slice is what you get on a public network if an operator wants to give a certain kind of quality to a given type of services, right? They could be automotive, connected cars moving through the country, and they need to have a certain quality of service. Now, private networks are rather different if you think about dedicated private networks, where an enterprise wants to have its own coverage within its manufacturing plant, say a car manufacturer, hospital, utilities, so, solar plants and so on. They want to have their own coverage, and there they want to have full control of a network that nobody else can use. And that, brings the two really apart. And there's been a lot of discussion on how the two can interact. And that's an important, very important aspect, right? Because it is important. If I am the doctors in the hospital, due to the secure HIPAA requirements, they can access certain data within the hospital that they can't access outside. They shouldn't be able to access outside, right? And there's many other situations that are similar, right? With manufacturing plants, airports, and so on. And therefore, to be able to make the two work together, you need to be able to give those devices connectivity when they leave. Maybe it's not the same security profile that they had before, but they need connectivity to be able to, download their emails and do whatever they're allowed to do. And in that way, you need to and then the device is really fundamental there, right? What do you do? You can do, there are multiple solutions, but I won't go into the details, but really eSIMs, electronic SIMs that are available in, the iPhones, the various, Google Pixels, Samsung phones, and so on, that are out there, allow you to have multiple SIMs on the same device, i.e. I can be within my solar plant and at the same time, in fact, we have a specific case where we are actually doing that right now in the US, where I'm inside and I'm connected at the same time both to my public operator network and my enterprise network. So I can access my special applications, sensors, and so on at the same time as I can access my public network. When I leave, I am on the public network only. So there is a way to do it. There's a lot of complexity. The devil is in the details. And I strongly suggest to use integrators that are highly skilled to be able to set you going, because making mistakes on SIM cards sometimes means going and having to redeploy 10,000, like schools in the US, right? We're seeing tens of thousands of SIMs being deployed. You don't want to make mistakes there and have to replace them.
Right. Okay, great. And I have a bunch of questions here about CBRS, and Safi, you did touch on CBRS in your presentation, and I know you and I have previously talked about CBRS spectrum and how, the role it plays in this whole conversation. So can you just, explain a little bit more about that?
Sure. So CBRS stands for Citizens Band Radio Service. And this is a slice of spectrum in the 3.5 to 3.7 gigahertz range. It is also called mid-band spectrum. And what the US government and the FCC did is it was previously used by the US Navy for radars. For ships, when they come into the port, they would communicate with the ground using this spectrum. And it wasn't really used that much. So they opened up this spectrum for sharing with Cellular. And this is a service called OnGo by an alliance, an entity called the Cbrs Alliance. And it has really taken off in a very big way in the North America for private LTE and private 5G networking. 3GPP technology is allowed to be deployed as long as the devices can still allow the incumbent, the US Navy, and some wireless operators who have a previous license, as long as there's devices that can listen to the Navy trying to talk and they shut down everybody else, they are allowed to basically use this shared spectrum. And what this allows is to bring the cost of ownership of spectrum much below the cost of licensed spectrum, but still get the benefits of a cellular technology being deployed. And what they did even within that is have 3 tiers of service, so that tier 1 is the incumbents, the Navy, which is only on the coastlines of the continental US, but still also very scarce or very rare. And then the second tier is called priority access lane, so which is basically what the auction that happened a couple of months ago concluded with $4.6 billion being spent on that spectrum. So lots of demand, and that spectrum was taken up very quickly. So these PAL licensees actually are allowed to operate a cellular service on a license, it's on a shared spectrum, but they've paid for the license. So the other devices will not cause interference. The only interference they will see is when the Navy is interfering. But that's supposedly going to be very rare. And then the third level, which is the lowest level, is GAA, which is General Authorized Access. So this is equivalent to Wi-Fi, where you're not paying for the spectrum. You will pretty much be paying for, let's say, the SIM card and the service provider and the system integrator for putting the network together. But basically, the devices can be low cost and have cellular connectivity, such as the LE915 that I mentioned, which is CBRS only.
Okay, thank you. And Stefan, there's a number of questions here about the data that you shared. So I wanted to give you an opportunity to address some of those, particularly, more information about how that data was collected.
Yes, so I only presented a very limited set of data coming out of that testing, and the testing is continuing to be ongoing. As you can see, the chart that we shared are effectively really testing for long-term reliability. So effectively, some of the tests you've seen have been running for several weeks to be able to get to the 4 nines or 5 nines testing that we've done. As I mentioned, that was tested in a manufacturing-like environment. I saw a few questions which I will address here. Regarding the loading, for example, I was asked what was the loading. The load condition that I've shared here was a combination of 20 different robots sending heartbeat combined with a streaming 10 megabits traffic on the same link. So I'm addressing this question as well because I think it can explain a little bit, some of the chart. I've seen a few comments around latency testing on Wi-Fi 6 that significantly improve the latency, and this is correct. Wi-Fi 6 does improve the latency by having an uplink OFDMA scheduler, which we saw an impact on that even on the single user testing with a better performance beyond 3.9. So we've seen that effect. As I mentioned, we are yet to receive sufficient device to be able to test loading with not just increased loading on the link, but also increased loading just in terms of multi-user on the same link. So I've also wanted to address that point. So those results will be published. You'll get a lot more details. And finally, I'll add, we tested with 3 different vendors, Wi-Fi 6 access point, to make sure we got a good representation of different implementation, different types of chipset, but also different software code, including Nokia own Wi-Fi 6 access point also, again, to try to get a really fair point. Because initially we were really struggling to find Wi-Fi 6 access point that had the uplink scheduler enabled inside. It looks, and we now finally got those. So a lot more detail will come in a very, detailed technical paper that will be coming very soon.
Okay, perfect. And I'm going to try to squeeze in one more question for, Karim and Safi, which might put us over by a few minutes, but bear with us. So Karim, are private 5G standalone networks easier to set up versus proprietary LTE technology due to O-RAN and other standards like that?
So yeah, private 5G networks are not any simpler to deploy, and in fact, newer technology very often is not easy to deploy. But it really depends on the approach. What I try to talk about in my slides, in my talk, is that if we leverage what's going on in the cloud and edge computing and the automation, you can make it easier. So it's really the choice of the end customer, how they want to deploy and what they want to deploy. We've always seen that flexibility on the radio is important. You may be agnostic on that front. You may go from different types of radios, but you need to build your platform and own your platform, right? And be able to manage it. That's fundamental because you need to own that network. And that's been a fundamental realization that we've had throughout. And it is really on the radio side. O-RAN can be a very useful technology in lowering the prices. It can help operators a lot in making the network more efficient and more cost effective. We're still trying to understand how this can affect enterprises. We hope it can, but it's not like an enterprise will be deploying 50,000, 100,000 base stations like an operator will. So the question is, how much easier will it make these networks to be operated, right? And once again, the platform that I mentioned before is really what you're looking for, the network intelligence. You put in the radios, right? Of course, cost is important, but most of the focus is on the OPEX, right? Is on your operational cost. Can you manage that platform? And you know, I saw another question. One of the pictures that I had in the slide is this AWS snow cone device, which is actually an edge device that you can run applications on, right? And the whole point is, how can I streamline everything and make it easy for me to have an overall low cost and an overall low OPEX cost? O-RAN can be a part of it, but it is certainly not what I would, you know, the single focus.
Okay, great. And you started to talk a little bit about costs there. And so for our final question, I'm going to ask Safi to expand a little bit on the cost of a private network compared to a Wi-Fi network, because I know this is obviously a very important thing for enterprises.
Yes, yes. So I think that, you know, it's clear, like I said earlier, that the total number of small cells that are needed to cover an area in cellular, that's lower than Wi-Fi. So you need fewer small cell units to cover an area versus Wi-Fi. So you would have to deploy many more access points to cover the same area versus cellular. So in that sense, that what we'd call CapEx would be lower for cellular and higher for Wi-Fi. On the flip side, the operational cost for Wi-Fi is lower than that of cellular, simply because you have to also do the SIM management, the device authentication, and so on, and basically you have to maintain the core network. And that's where solutions like the one from Ethernet and Nokia are helping to drive that cost down. But there's no question about it that Wi-Fi is very ubiquitous. The costs have really been driven out because of the economy of scale. So the OPEX for Wi-Fi would be lower than that of cellular at a higher level. And of course, you can still optimize it, but just from a very high level view, you can imagine that a Wi-Fi network system cost of operating it would be lower. And now you really have to look at the case-by-case example, like a large enterprise building would have a different profile versus like a mining operation or a hospital or a railway port. And so there are other factors to consider when you look at the overall cost, which is it purely an indoor deployment or purely outdoor or mixed? And then, you know, is it a harsh environment? Is there other machinery and other sources of interference? And that's where, you know, some of the issues with Wi-Fi are something that you have to take into account.
Okay, great. And Stefan, did you want to add anything to this whole cost discussion?
Yeah, thank you, Kara. You know, very good answer, Safi. And I think it is a really complex picture. And you know, I just wanted to mention that Nokia built a very advanced TCO tool to really look into that matter. And that tool is available on our website. So if anybody's interested on that topic, they can go in there and get a simplified version of the tool where they can effectively look at a different environment and be able to see the cost of a private wireless network, but also the comparison between a private wireless network in licensed spectrum, a Wi-Fi 6 network, or a private wireless network in unlicensed multifier. So anybody's interested, you can go in there and actually play around, you know, a specific site, different types of industry, different types of spectrum, and get an answer to that very complex question of total cost of ownership.
And also I would add that the Cbrs Alliance has also got some white papers that analyze or compare this TCO, which is the total cost of ownership. So you can also go there. Perhaps in the resources link, we can send these links to the viewers so they can have those links offline.
Yeah, that was all really great information and solid resources for our listeners. And with that, that's it. Thank you all for joining us today, and a special thank you to our speakers. Remember that the video and slides will be made available on demand in the next few days, and please keep an eye out for the related report coming out soon. Have a great day, everyone.
Thank you.
Thank you.
Thank you. Bye-bye.